Welcome to Beyond Bandwidth, Leviton's podcast series where we dive into network technology's hottest topics. I am your host from Leviton Network Solutions, Roy Chamberlain. In Season 3, our topic is extended distance applications, and primarily extended distance using category copper cabling. Since these applications are beyond the industry standard limits, how do we test these alternative solutions with confidence? In this episode, our guest host, Todd Harpel, meets with Jim Davis, a senior product applications specialist at Fluke Networks. Their discussion is loaded with answers to testing questions everyone needs to hear.
Well, welcome everyone to our podcast on cabling beyond 100 meters using copper. Today, we are talking with Jim Davis, product application specialist with Fluke Networks. Welcome, Jim.
Hey, glad to be here. Thanks for having me.
We're excited to talk about this. There's a lot of people out there that are curious about how you would test and, a lot of the things that go on when you are doing installations that are necessary to give your customer the final verification of all of the channels you've installed. I know one of the questions that often comes up for us is when an installer goes to test an installed link or channel as part of their final qualification, what typically happens when a link is longer than 90 meters or a channel is longer than 100 meters?
Oh, big trouble. The structured cabling police come chasing them down. No, sorry. Just real quick, we're going to run a test. We're going to measure signal. We're going to measure noise. But the limit that you pick is what's going to determine what's acceptable or not. Sometimes people they've got an emergency phone in a parking lot. We've got limits for that that'll go farther. But I'm sure you're referring to things like a TIA 568 limit. Now, you can go over it a little bit, 10%. It understands that. But after that, you're probably going to fail for length. Now, that might be because you've got the wrong NVP, the speed of the signal in the cable. But if that's correct, you'll fail length. And after that, in pretty short order, you're going to fail something called propagation delay. And then the signal strength, insertion loss, decreases with distance.
I had a feeling that was the case. Having been on job sites in the past, in my past life, and witnessed the testing, certainly there are situations where you get a fail on your test result, and then you always start to look at what is it that failed. But one of the other questions that I have is, let's say you're measuring to TIA Cat6, and all your other parameters like crosstalk, insertion loss, return loss, wire map, even propagation delay, all fit within the expected parameters, but you're still longer than 110 or 110 meters. Will the tester still show a failed result?
Yes. Now, in that condition that you're painting for me, where you pass insertion loss, and especially propagation delay, sometimes it's not quite understood how we measure the length. We're actually measuring the length in time. We send a pulse down the cable and we see how long it takes to get back to us. Divide that in half, and that's in time how long the cable is. Now, a variable is the nominal velocity of propagation, the speed of the signal in the cable. So if you have the wrong NVP or the wrong speed of the signal in the cable, you might get a false failure for length. And that would be called out because you passed insertion loss and you passed propagation delay. A curious thing that some of our audience might save for bar trivia at a Bixie show, there's some subtle differences between the TIA 568 standard we use here in North America and the international, the ISO 11801 standard. The ISO 11801 standard doesn't have a length limit.
Interesting. And now that you say that, I believe that the IEEE Ethernet transmission standards also do not specify a particular length. They really specify electrical parameters, electrical performance for the actual signal that the Ethernet speed for which you're testing is going to require to ensure that you have the ability for the receiver to get the transmitted signal and interpret it. I know that Fluke makes a tester that can test installed channels' ability to support a specific Ethernet speed between 10 megabits or 10 gigabits, and it's a specific type of tester. Can this actually conduct an Ethernet speed test on a channel that is longer than 100 meters?
Thanks for that question. And I think we're kind of mixing two things there. One is, and I'm glad you're bringing it up, the 802.3 standard. We always need to consider today's applications and tomorrow's applications, what people are going to build to. And the 802.3, the Ethernet standard, the IEEE standard, is certainly something that people look to. It doesn't say in words you have 100 meters, but it does call out a propagation delay limit. So they're taking that into consideration. They also take into consideration, we've all looked carefully at the cable under the jacket, I'm sure. And we know that some of the pairs are a little bit more twisted, some are a little bit less twisted. That'll minimize the noise, the crosstalk under the jacket. But physically, each one of those pairs has a slightly different length. The one that's more twisted is a little bit longer. Most of our links are going to have Ethernet installed on them, so let's just talk about Ethernet. Ethernet has a tolerance for when that signal can be put back together. So if we exceed that tolerance, and as the cable gets longer, that delay skew gets wider, we might not be able to support everything. Now, thank you for asking about our trusty Link IQ tester. But the way that Link IQ does its testing is essentially it's measuring against the ISO 11801 limits. So we're measuring length and insertion loss and near-end crosstalk and return loss, but against kind of those 100-meter values. So if your link exceeds 100 meters, say it's 150 meters, we're going to fail that based on the wire map length, and also we'll probably fail that based on insertion loss. So no, it's not a valid way to test the speed for Ethernet.
Oh, yeah, I didn't think so. I know that aside from testing, we've had customers come to us and say, hey, we have channels that are beyond 100 meters. We went ahead and hooked up two devices, and we got the little green lights to come on either end, either on the switch or on the device, oftentimes a camera or wireless access point. And those green lights come on, and we assume that it's going to work. It could work depending on how long you really are. If it's 180 meters, there's less of a chance than it working if it's 110 meters. But they're assuming that the little green light is actually going to, on the transceiver, is going to actually guarantee that you're going to have a functional piece of equipment. And without the ability to actually see data being passed, or let's say if it's a camera, being able to see the actual image come across, it's tough to say whether that's actually going to be functional or not, because I don't think the little green light test is necessarily valued.
Yeah, I was going to say that little green light is our biggest competitor.
Yeah,
I had to prepare a chart about that. And our second biggest competitor is your buddy who did this at his house, and it worked fine.
Exactly. Yeah, we did it and it worked.
Yeah. I have a real live fun one where they plugged in two laptops and little green light came on and the laptops worked. Then they plugged in the cameras and the cameras didn't work. So obviously it was a camera problem and not a cabling problem. Turned out to be a resistance unbalance issue that only showed up when they turned on the PoE.
Right. That's actually what I was going to get to next is the PoE power. I know, we all know that PoE power delivery is DC voltage, and the longer the length of the cable, the more the DC voltage drops. And you have a tester that can evaluate channel and indicate the PoE power level that it can support. Can you tell me a little bit about that capability?
Sure. We try to focus very much on standards compliance. I want to kind of preach, here's what the standard says, because there's interoperability. And so this is that same Link IQ tester that we just found out won't tell us if our 150 meter cable will support 10 gigabits. It is testing very much to, speaking of the IEEE, the 802.3 AT, AF, and BT standards. It'll test out to class 8, 90 watts of power. But it's measuring two things. The first thing that it checks for is what is the switch advertising? Different switches, different ages, different capabilities. Older switches can't offer 90 watts of power. And if you have a switch that can offer 90 watts of power, you might not want every port to do that because you've got a lot of devices. So they will advertise what they're capable of offering or what they're told to offer. So we'll measure what is advertised, but then we do a load test where we say, hey, you're offering me 90 watts. Give me 90 watts. Let me see if I get that much power. So and here's the fun thing, the standard, it's just a recommendation. It's a best practice. But the laws of physics come into play, as you well mentioned, and there's more resistance there. And when there's too much resistance, we're not going to be able to get that power there. So if somebody, maybe they bought some cheap cable, some non-compliant, some copper-coated aluminum cable, you don't even have to go 100 meters on that, and you're going to get too much resistance to supply the power level. But if you have perfectly good 6A, larger gauge size cable, we are looking for standards compliance. And so if we don't get the power levels that we expect within the expectations of the standard, we'll fail that. So it's not an ideal way to test non-standards compliant power levels. I have a little cheap off-brand switch, power over Ethernet switch that I bought for trade shows. Works great. And it has standards compliant ports, and then it's got a special port that offers high PoE, which I always translate in South America as Ola PoE. But sorry, I can't resist. But it's not standards compliant. So I would have to have a device from the same off-brand company, no offense to them, but it would have to match up to their special sauce, their secret power supply. So no, our tester is really looking for standards compliance. And if you're going outside of what the standards have defined, then no, we're not going to be the best solution for that.
Sure. Although today we're seeing most of the major cabling system manufacturers in the market are launching cable or have launched cable or a cabling system that includes a special cable designed to support channels longer than 100 meters. I'm curious, is there a way to use a Fluke tester to get these channels to pass so that they can be submitted to the customer so the contractor can get paid?
Yeah, absolutely. We appreciate, for all my talk about following the standards and the guidance of the standards, the people say, yes, but I have to put a sensor on the roof to tell me if the fan is going, and it's just too far away. So if I follow the standards, I've got to put another telco room. So I'm going to have a telco room with a door and a lock and a rack and a smoke detector and a sprinkler head. And it's going to cost me $10,000 to put a $3 sensor on the roof. So I'm going long. In those situations, the airports are another one where the people are like, no, there's no way we could dedicate 3 square feet to a cabinet. We need to go long. Work with your connectivity manufacturer to say, here is the application that I want to support. I want to go this far. I need this speed. I need this much power. What do you recommend for me? Because I know that you have category 5E and category 6 and category 6A. And no customer is going to say, oh, give me the top of the line thing. They're always going to say that's too expensive. But you and your engineering team can work with the customer to say, hey, for this application, we recommend this cable that we have. And more, we recommend these connectors in this patch panel to go with it to make a complete system to get the performance that you're looking for. Now, you need to test that. I don't make the numbers up. I'll reach out to you as the manufacturer and say, what numbers do you want? And I know some of your guys from the lab, from the BerkTech days, and they're good people. And they're studying this, and they're saying, what are we capable of doing? How far can we go with this? And they'll say, Jim, here are the limits that I have. Here is the length. Here's the propagation delay, the length and time, the delay skew that I want. Here's the new curve of the insertion loss. I need you guys to supply that formula. It's a tricky one. And then whether or not we measure loop resistance, what value we use. So yeah, we'll work with the manufacturers. Again, we just take a measurement. You guys can tell us, here's where the limit line needs to be so we can make sure it's installed properly. On one hand, I want to tell people, hey, you got a failing result, but it's just length. Don't worry about it. But I don't want the technicians to have to look at a failing test result and accept it. I want it to be green, good, they're happy, they move on, or red, bad, something's wrong. And I hate to say, oh, it's a little bit long, don't worry about it, but they don't notice that it also failed return loss or something. Mm-hmm. Sorry, it's kind of a long answer there.
No, that's okay. I mean, I know for us here at Leviton in our BerkTech labs, we've created a cabling system that allows you to go longer than 100 meters. And we've done just that. As you know, we've created the limits that we believe will still allow that channel to function at the specific speed that you're targeting for that particular channel to use, right? You have a specific device. So unlike a standardized test for TIA category, we have a different set of parameters for our specific channel. And it's, I believe, if I'm not mistaken, that similar to us, there are other manufacturers out there that have similar test settings, if you will, for their particular channel.
This is something where it's important, and I've spent many years going out and defending the standard and saying, follow the standard, And people have resisted. I remember saying you need to install 4 pairs. People are like, 4 pairs? You're an agent of the Peruvian and Chilean copper mines. I'm only using 1 pair to transmit and 1 to receive. I'm only going to install 2 pairs. I'm like, no, please follow the standard. We spend all this time convincing people to follow the standard. People did. And the market has accepted the standard, and people who followed the standard have made it easy for new things to come out, like voice over IP or power over Ethernet or N-base-T or whatever the next thing is going to be. I don't know what the next thing is going to be. If I knew what it was, I'd be buying stock of that. But whatever the next thing is, it's going to be designed to work on 100 meters. So when somebody comes along and says, oh, don't worry about the standards, do whatever the heck you want, I'm suspicious. And so I like your idea of saying, hey, let's be careful about this application can only go this far. And we've got a whole package. Because again, it's not just cable. You also have connectors and patch cords. Can I use the skinny patch cords with this? Or do I have to use full-size patch cords? Do I have to use solid conductor in my patch cords? Which patch panel will give me the best performance for this? So I appreciate, and I would suggest to people who are going to go beyond 100 meters, but for their situation, to work with their supplier to make sure the supplier is going to back up what they're promising the product will do.
And I agree with you that when you're going outside the scope of the standard, the term that is thrown around is engineered link, right?
Yeah.
Designating that link or that channel to a specific speed, PoE power level, depending on how long it is. Because one of the things that I think you'll agree with is that if I want to use gigabit Ethernet at a longer distance, the capability for the most part is going to be a little bit shorter than if you're using 10-base-T, for example.
Absolutely. Absolutely.
I think the situation that we're running into more often is we've got, like you mentioned, I've got a sensor, or I've got that one wireless access point, or a security camera mounted outside the building that I can't quite reach the closet inside the building within that 100 meters. And I need a solution for that. And you already mentioned it. There are other methods for accomplishing that involve a lot more cost than simply running a cable beyond 100 meters. It's one of those things that we're seeing pretty often. And how often are you being asked about this specifically for like the test parameters and those kinds of things?
Yeah, I would say today, I don't get a lot of questions about how do I test category 6. People understand that. We like to talk about cabling. This is our life. We enjoy it. And yeah, one of the questions, more common questions is, hey, how do I go more than 100 meters? How do I set up the tester? The other question is, when are we going to get an MPO tester for Versiv? But that's fiber, so we won't talk about that today. But absolutely, people are curious about this, and they want to do it the right way because they want to get called back and keep working with that customer in the future. And if they install a link that doesn't work, that's not going to get them back there.
Exactly. One of the things I would like to mention is the standards. We talked about the standards a lot. The TIA TR42.7 Standards Committee, one of those committees that created a lot of the TIA standards, or most of the TIA standards between the TR42.7 and 42.1 and 42.5, have created all these different standards over the years. And now they're looking at writing a technical services bulletin, or TSB 5073, on extended distance over copper cabling. One thing I want to make sure people understand is that a TSB is not a standard that a cabling system can be designed to. It's a document that gives technical advice on what the risks are and what mitigation factors can be deployed if an extended distance channel ends up not supporting the intended application. I actually happen to be the editor of that particular TSB, as I'm part of the TR42.7 committee. One section of the document is going to give advice on field testing of these extended length channels. If you were to provide input into the committee itself on testing extended distance channels, what are some of the things you would recommend they include?
Well, first of all, let me thank you for your contribution to the standard, because that is a noble job, but also sometimes a little bit thankless. It's tough to herd the cats there. So thank you for your work on that. I kind of hope that there's a comment that says, hey, we encourage you to stay within the limits if you can. I don't want people to go willy-nilly building whatever lengths they can. I hope that there's a limited number of variables. I hope that we don't have a performance for 130 and 150 and 170 and 175 meters. It needs to be understandable for people. One of the things that I saw that they're thinking about putting in there is some consideration for the labeling standard, the TIA 606. And I like that because the next IT guy needs to know why there's a piece of tape on this one outlet on the patch panel, so they don't upgrade all the cameras at the location and find out that half of them don't work.
Yeah, I'm glad you mentioned that. The administration of a system that includes mostly TIA compliant channels, but then also deploys a few extended distance channels. And you got to keep track of those particular channels as you administer. The IT manager administers the whole system. If they don't know that that particular location is, 130 meters.
Yeah, that was tribal knowledge, and that left three IT guys ago.
Exactly.
And so then, of course, you're just going to have to take into consideration those parameters that are most affected by the length, the propagation delay, how long it takes to get there, the delay skew, the different lengths of the cable, and of course, the loop resistance. There's a limit to what PoE is expecting for that loop resistance. Of course, insertion loss will change because that's so affected by distance. That'll probably also screw up the parameters, the attenuation to crosstalk ratios, the ACR near and the ACR far end. That's some interesting work, and I hope that some of our fancy engineers will also be contributing to that to make sure not only that the cabling people come up with a super fancy cabling solution, but it's something that we can test to. we gotta both work on these.
Exactly. So I just wanted to mention once again that TSB is not a standard to design to. TIA has routinely issued TSBs because they want to issue technical guidance to people. And they're generally for things that I would say use of a cabling system or a cable for which it's not actually designed for. And I hearken back to the days of TSB 155 when 10G base T came out and everybody said, well, can I just deploy 10G base T on my category 6 cabling?
Out to 55 meters, yeah.
Yeah, exactly. Everyone said, well, TSB 155 says if I go only 55 meters, people were starting to design new cabling systems with that in mind, which was not the intent of the TSB. It's a little bit of trepidation that we're developing this new TSB, but we feel it's important that people understand, and companies like Fluke that have the ability to do the proper measurements and inform the user of what the capabilities of those longer distances is really important.
Yeah, we can't be separate of the market. If the market says, hey, I've got to go more than 100 meters, and we say no, then people aren't going to follow the standard at all. So we kind of have to give them an out, but let's recognize where the years of effort to get people to build the same structured cabling, 4 pairs, RJ45 connectors, patch panels, administration points. They do that everywhere in the world. So when someone comes out with a new access method or a new widget, that's going to get great uptake. There's a lot of market for that to work with. So yeah, there have to be some edges. We can't require 6 pairs. There's not going to be enough market for that. So I appreciate you bringing up the TSB. And again, as much as certain manufacturers would rather say, haha, I've got the secret formula and only I can do this, it's kind of better for the market if people are kind of following the same path to get there.
Exactly. Well, I appreciate your time today, Jim. It's been great to talk to you, and I hope that our listeners have understood some of the complexities with these extended distance links, but are reassured that Fluke has the ability to at least inform them of what the capabilities are, and your great advice on make sure you're working with your system manufacturer and getting the proper test limits from them, because they're the ones that provided them for their cabling system.
Yeah, no, hey, it's been a pleasure. Thanks for reaching out. I very much enjoyed the conversation.
Beyond Bandwidth is a podcast series produced by Leviton Network Solutions. For more information on the topics we talked about today, as well as other enterprise or data center network infrastructure content, or to check out all available episodes of Beyond Bandwidth, visit us on the web at leviton.com/beyondbandwidth. or wherever you normally listen to podcasts. If you enjoyed this episode, we'd appreciate you leaving an honest review in your podcast application. Along with word of mouth, leaving a review will help others find our show. I'm Roy Chamberlain, and this was Beyond Bandwidth. Until next time.